Welcome you all in the 11th lecture of Electronics Measurement and Instrumentation. So, in this lecture, this is the part 1 of the CRO. So, in this lecture, I will cover what are the front panel controls of the CRO. So, as we know, we will study the CRO which is available in our laboratory, but apart from there are so many CROs that are used for the different applications. Like you can see here, it is a CRO. This is used for the medical purpose, and whenever you ever you have a chance to go in hospital, then you have seen this type of CRO in the operation theatre and other places. So, this is also a type of CRO. It measures the pulse rate of the patient and the heartbeat and other things. Similarly, if you ever have visited aeroplane, then you have to see the cockpit of the aeroplane, that there are number of CROs available there which controls different what is the height of the what is the height of the aeroplane and other things. So, that gives the clear picture to the pilot. And similarly, if you get a chance to visit the control room of the flight control room, then you will see there are also so many CROs, the different type of CROs available there. And by seeing that the whatever the display that is seen by the persons who are available there, they controls the flights of the different positions, ki where the flight is going to land or other things. Similarly, you can see when there is a launching of satellite takes place, or when the launching of any other things takes place, then there is also the scientists are looking after the CRO, the different controls of the CRO. So, these are the different applications of CRO. They are slightly different from the CRO that is available in our laboratories. So, in this lecture, I will cover what is the front panel of the CRO and how we control, how we have to see the waveform characteristics by the CRO. Then there are different applications of the CRO. So, this is the front panel of a particular CRO. So, the first thing that this is the screen. So, screen is generally of fluorescent screen is there, and in general the green color is preferred. And what is the function of this fluorescent screen? That if any spot electron beam strikes on this screen, then the property of this screen is to convert that spot, that electrical signal, that is because of through the cathode ray tube, into the luminous spot. Means it is converting the spot which is striking this screen into a waveform. So, we can see the waveform on this screen. So, this screen basically displays the shape of the waveform, and by that shape of the waveform we can measure. First of all, we can see whether the waveform is AC or DC. Then if it is AC, whether it is periodic or non-periodic, and if it is a periodic, then we can measure the time period of the waveform, and we can also calculate the frequency. So, we can analyze the peak to peak value of the amplitude, and we can find out the amplitude of the signal, we can find out the time period of the signal, the phase difference between the signal, and so many characteristic we can find out from this CRO. So, first of all, when we want to use the CRO, then the first switch is, that is the on off switch. So, by pressing this switch, the CRO will be in on state. So, after that, when we want to see any waveform, or we want to analyze the signal, the output of any circuit, then that circuit we have to connect with the BNC connector to this knob. This is basically 2 channel CRO. So, there in this CRO we can measure or we can analyze 2 signals simultaneously. So, when we want to measure one signal, then we can apply that signal either at channel 1 or channel 2. So, there are so many type of probes that we can use for the measurement of the signal. So, suppose we want to see we want to measure the amplitude of a signal. So, that signal is applied at suppose channel 1. So, channel 1 means the signal is applied at channel 1, then we will feed the signal from the output of the circuit whose signal we want to analyze to this point. So, we will connect this the BNC probe at this point, and then if the signal is DC, if we already know here signal is DC, then we put this switch. There is a switch which has 3 positions DC, AC and ground. So, if the signal is DC, we will put this knob at DC position. If the signal is AC, then we will put the knob at AC position. And if we want to find out where is the axis of the signal, suppose there is a AC signal or there is a DC signal, then where is that 0 point of the signal, then we will put this knob at the ground position. So, when the knob is at the ground position, it means it shows what is the origin of the signal. So, suppose we want to measure DC signal, so we will put here at the DC level. Then if we want to invert the signal, means we want to invert signal means we want to deviate the signal from 180 degree, means positive to negative, negative to positive, then we have to push this button invert. So, it will invert the channel. Then if a waveform is displayed over there, then we have to vary the voltage per division. There is a knob of voltage per division. So, it means suppose at this position, if you see this knob is at the 2 volt per division. It means generally if you see the screen of the CRO, so it has 8 vertical divisions and each vertical division has a 5 subdivisions. So, if this knob is at 2 volt, it means one division is having a value of 2 volts. So, this one division is having the value of 2 volt means if it has 5 subdivisions. So, it means one subdivision value is 2 divided by 0.5, 2 divided by 5. So, 2 divided by 5 means 0.4 volt. So, whatever our signal is displayed on the screen, we can calculate what is the value of voltage, what is the peak to peak value, what is the amplitude of the voltage. So, suppose if signal amplitude is very small, we want to see in increasing amplitude order, then we will put this knob from 2 to 1 volt and simultaneously we can shift the button this. So, by selecting volt per division knob, we can select the variation in amplitude of the signal. Although the signal amplitude is same, but we can minimize or maximize the signal amplitude by varying this position. So, this is about the channel 1. Similarly, if we want to measure 2 signals, then we will put the second signal on the channel 2. We can use channel 2 also when we want to measure only a single channel or single in output, then we can also use channel 2 also. So, in channel 2 again if we want to measure 2 signal or single signal. So, if we want to measure it by channel 2, then we will put the output of that circuit to this position and again we will select whether if signal is DC, AC or ground by varying this voltage. Then if we want to invert the signal, we can invert the signal by pressing this button. Then this is one more switch, Y position. Y position means we can vary the position of signal by varying this knob. So, suppose a signal is displaying at this level, suppose a signal is displaying at this level and we want to display it at this position. So, we can vary this knob and so this signal will shift, we can shift upward or downward. So, what is this Y position is basically it is shifting the this position of the signal, that is the mid position of the signal at the Y direction. So, this is all about this channel. Then there is 3 switches, one is trigger, channel 1, channel 2. If switch is in out position, then initially it is triggering channel 1. Suppose we want to trigger channel 2, then we will press this switch and when we press this switch it will select the channel 2, it will trigger the channel 2. Then there is dual. If we are using both channels simultaneously, then the switch will be in dual position. If we are not using both the channels, then this dual switch will be in out position. Then suppose we want to add both the signals, then we will press this switch and this will add both the signals. There are two things generally, one is chopped and other is alternate mode. So, in alternate mode what will happen, both the channels are applied simultaneously on the CRT and there is a switch, maybe a FET switch or the transistor switch, which vibrate from one channel to other channel and it will displace, since the velocity of the switch is very high. So, our eyes can't distinguish ki there is two waveforms displayed. There our eyes will see, yes, there are two waveforms which is displayed on the screen, but that waveforms are displayed alternatively. So, as you know, the persistence of vision of our eyes are that if more than 16 pictures pass through our eyes, so our eyes are unable to distinguish the difference between these. So, similarly, we will see both the waveforms on the screen, although it is alternatively fed to the vertical deflection plate. In chopped mode, in chopped mode, basically multi-vibrator is used and the switching speed is very high with respect to the alternate mode. Then there are so many switches also. There is one switch that is XY switch. So, XY switch, what is XY switch? Suppose we want to use one signal as a trigger, means we have two signals and one signal we want to use as a trigger. So, we will off the trigger pulse, which is internally generated signal, and we will push this switch. So, at that time what will happen, the Y channel, the second channel signal acts as a trigger pulse for the first channel, and then we will get different shapes. By different shapes, suppose we want to measure the frequency. So, what we will do, we want to measure frequency of unknown signal. So, we can measure it by comparing the known signal. So, known signal is applied to channel 2 and unknown signal is applied to channel 1. So, and we vary the frequency of the known signal, known standard signal. Then what will happen if the known signal is multiple or sub multiple of the unknown signal, then we will get different shapes, and by using the formula we can find out the frequency of that signal. So, that is XY switch. Then there is an intensity switch. So, intensity means there is a cathode ray tube. So, cathode ray tube, there is an indirectly heated cathode, then there is a control grid. So, this intensity means ki it basically increases the intensity, or we can say the brightness of the signal or the display. So, to increase brightness, what we will see, what we will do, we will increase the voltage at the control grid. So, we will study in the second part of CRO, the CRT, then we will see how we vary this intensity. Then there is a focus. Focus in CRT, there are focusing anode, pre-accelerating anode and accelerating anode. So, by varying the voltage at focusing anode, we can focus our signal very sharply. So, to increase the sharpness of the signal, we have to vary the voltage at the focusing anode. So, focus means key sharpness of the signals. So, there is this knob, we can vary it, and so the width of the signal or the sharpness of the signal will increase or decrease as per our requirement. Then in previous time, in old time, there are oscilloscopes where we are using this when we measure the composite signal. So, at that time there are some knobs, the triggering pulse is applied because the normal triggering is not able to see the composite signal. So, we know the video signal of any TV or the audio signal is a composite signal. So, when we want to measure that composite signal, then we have to switch, we have to press the switch at that position. If it is AC, DC, so high frequency and composite signal, if it is high frequency and composite signal, then we will put the knob at high frequency. If it is low frequency composite signal, then we will put the knob at this position. Similarly, if there is an triggering, basically the triggering pulse is applied inside, from the inside of the CRO. CRO is having a circuit that generates the sawtooth wave. So, sawtooth wave signal is used to move the electron beam from left to right. So, if we want to apply synchronous signal from externally, so at that time we will press this external switch. This switch is out when we apply the internal synchronous signal, and if we want to apply the time based signal, a trigger signal externally, then we will put it at the external position and we will press it, and then we will connect the external circuit, the triggering circuit at this position. Then there is this plus minus. So, if we want to change the direction of trigger from plus to minus, then if already it is out, then it means ki the plus triggering pulse is applied. If we want to apply negative trigger pulse, then we will press this switch. So, there is one more switch, that is the time per division. So, similarly, as we know, we want to measure the amplitude, or we want to vary the display on the screen in terms of amplitude, then we will put this volt per division, we will change the volt per division. Suppose we want to increase the signal at this screen, then we will put this knob at the lower position. So, here it is shown here, the millivolt means 25 millivolt, 10 millivolt, 20 millivolt, 50 millivolt, and then 0.1 volt, 0.2, 0.5 and then up to 20 volt. So, you see 20 volt is the maximum limit, 20 volt per division. It means in this CRO the maximum that we can measure is the 20 multiplied by 8, 8 divisions are there. So, 20 into 8, that is we can measure 160 volt maximum. So, if we want to measure the voltage which is higher than 160 volt, then we will use probes which is made up of 10:1. There are so many type of probes available, and 1:1 generally we are using probes, and then there are probes which is 10:1, then 100:1. So, as per our requirement we can use that particular probes. Similarly, yes, this CRO is also used for the calibration purpose. Suppose we are using a probe circuit, probes for the measurement of the voltage. So, first we have to confirm whether the probe is working properly or not. So, for this purpose we have to calibrate the probe. So, for the calibration of probe, what we will do? We will put the probe at this position. Suppose channel 1 we have selected. So, we will put our probe at channel 1, and then we will put the knob of this, the end of this. Suppose this is a probe. So, this is a probe. So, we will put this BNC at this position, and this terminal is at their calibration position, and then we will calibrate. We can find out the voltage till 2 volt or 0.2 volt. So, suppose we have put this knob at 0.2 volt, and then we will put the calibration, this knob at the calibration position. Then we will see whether the voltage is at of 2 volt or not. So, that way we can calibrate this. Similarly, we can see whether we can also see whether our component is okay or not. So, we can find out there are so many type of patterns given that if we want to see whether our resistance is okay or not, or a transistor is okay or not. So, that way we can measure that, we can see we have some patterns, and if the patterns which is we are getting from the CRO is resembles to that, that means ki our component is okay. So, if we want to test our component, then we press this component test at the this position. So, this is all about this yes, there is a time division time per divisions which is also there. So, suppose it basically if it by this we can measure we can change the time per division, means time per division means if this suppose this knob is at 20 millisecond. So, this is at this time 20 millisecond, it means one horizontal division is equivalent to 20 millisecond. So, suppose if a signal has very high frequency, then the time period is less. So, we have to increase the time period. So, we will put our knob at 50 millisecond per division. So, by varying this we can compress or enhance our signal to see the signal characteristics. Suppose we want to measure the frequency, then we have to expand that signal, and because of that we need this knob. So, time per division knob, whatever position it is at that time, that will tell the value of one division. So, there is one more switch, that is X variation. So, here is Y position shifting is there, then there is an X position shifting. So, by this we can vary the position of the signal in X direction. So, this is the front panel of general purpose CRO. So, here I have numbered it so that you can see what are the function of different knobs. There are so many variety of CROs available in the laboratory, and that also depends upon the manufacturer to manufacturer. So, suppose this is also a dual beam CRO. So, in dual beam CRO we can see there is one more switch, that is X5. So, suppose if our signal amplitude is very low, then we can multiply that signal by 5 by pressing this switch. So, this is X5 time, then XY, if we use both the channels, then we will put our knob at XY position, alt. So, this is another type of general purpose CRO. So, these are the numbers, the different controls are shown. So, these are the description of the different controls, that the first is power, then X5 and press give 5 times magnification of the signal. XY, as I have already told, it cuts off the time based internal trigger pulse, it cuts off the internal trigger pulse and it allows access the horizontal signal from the channel 2. Similarly, channel 1 to trigger, when we trigger for 1, then it will select the triggering of channel 1, when we select trigger 2, then it will trigger channel 2. And mono and dual, when switch is selected, when switch is out, it means ki single channel is considered. When we press it, it means ki both channels are simultaneously displayed on the screen. Similarly, alt, chop and odd means alternate and chop, I have already described, and if we want to add the signal, then we will press the XY button. Time per division selects the speed of the signal. Then similarly, auto and norm. So, in auto mode, enable stress when signal is fed to the trigger input, and in normal position the trigger level can be varied by the level given there. Similarly, trigger in socket, that is used to feed external trigger pulse when the CRO is in the form of external mode, then trigger pulse is applied to the external position. Similarly, X position knob basically controls the position of the waveform in the X direction, in X axis. Similarly, invert channel 2, I have already told if we want to invert the channel 2, means suppose we want to subtract from channel 1 whatever signal we have applied at channel 1, and we want to subtract the signal that is applied at channel 2. Then what we will do? We will invert the signal which is available at the channel 2, and then we will detect from channel 1 to channel 2. Similarly, intensity control controls the brightness of the signal and it is by changing the grid potential that I will discuss in next lecture. Similarly, focus basically controls the sharpness of the trace, and so focus control is there, and similarly other things for your reference. So, this is the picture of a laboratory signal, a laboratory CRO. So, you can see that we this is a slightly different CRO. Here whatever the position of this knob, that is shown here. So, at that time the channel 1 is at 5.5 volt per second and channel 2 is 5 millivolt per division, and the time period is of 2 millisecond per division. So, these are the different controls we have already discussed. Here one more, in previous CRO it is x5, 5 times we can increase the signal, but here the amplitude can be increased by 10 times. Similarly, mono, dual, add and all other things are same. Here there is a calibration out. So, we can put our channel, this knob, next slide I have shown. So, yes, this is the waveform displayed. So, we can see the waveform is at the outer at the upper position of the screen. So, we can put it at downwards. So, these are the display of signal, 2 signals simultaneously. I have applied at channel 1 and channel 2, and you can see the channel 1 is at 5 volt per division, channel 2 is at 1 volt per division, and the time period is 1 millisecond per division. So, that 2 waveforms are displayed. This waveform is basically we have varied, I have varied this Y position switch, and so we can see both the waveforms here. Similarly, 2 different kind of waveform, one is sinusoidal and one is square waveform is displayed over here. Then yes, this is the calibration. So, what I have done, we put this BNC knob at this position, and this basically there are 2 parts, one is positive, this red is generally used for the positive, and this crocodile point is used for the negative. So, this positive pin is put at this position, and so we can calibrate whether our this probe is okay or not. Suppose if it is showing 2 volt, it means the probe is okay, because we have put the switch at 2 volt. If it is not showing 2 volt, it means the probe is not okay. So, the application of CRO, I have already discussed. CRO is used for the measurement of voltage, current, frequency, inductance, admittance and other things. We can also compare phase and frequency of the 2 signal. This is also used for the composite signal measurement, like we can analyze the signal of the TV, radar and other things. It is also used in medical field. It is also used in EEC, EMG, ECG and other things. We can also find out the curve of the hysteresis curve. We can analyze the behavior of the transistor also. So, these are about this. Then there are many type of the probes, like this is known as BNC probe. Both the direction we can, suppose we want to measure the signal from the function generator, then we can put this probe position, this end at the function generator and this end at the CRO, and we can see the waveform. Then there is second type of CRO where the end is, both ends are the crocodile type clips. So, here generally this red is used for the positive point, positive signal measurement, and this is for the ground position. Then there are third type of probe is also available, where this is a pointed one and this is the crocodile. So, this red one is used for the positive position in generally positive and this is for the ground. So, this is all for this lecture.